Hello everyone, I am back in the classroom to record because I have a little bit of time. This particular note is extra. I will not be putting any of this stuff on either a logarithms test or an exam, but it does come up in calculus, which is why I am putting it as part of this Google site. We will go over it in calculus, your teacher will go over it in calculus, but I would feel bad not at least leaving an opportunity to look at natural logarithms. So I'm going to dig out my calculator, which I've got set up here. And I do want you to know that we have been hitting the logarithm button. Some of you have super special calculators that have the logarithm any base button. The original one that I showed you is log base 10 specifically. And then you have this other button, which looks like in, but it's actually LN, and it means natural logarithms, but because I think its founder was French, it's in the opposite order. And the short form is ln. So just like logarithms, you have to actually take the logarithm of something. So you have to take the natural logarithm of something. So you can't just have ln equals. It would have to be ln of something, and either a number or a letter would be sitting here. The meaning of ln is log base e, and e is approximately 2.71828, etc. You also have an E button on your calculator. It is right here. And if I hit it, I wonder what's going to happen with this particular calculator. Oh, there's the number. So it goes on forever. That surprises me. So, something you need to know is that e's and lns, and this is totally bad language for me, but e's and lns cancel each other out, but they don't cancel each other out typically like adding and subtracting, or multiplying and dividing, or square rooting and squaring. So we're going to cover that later on. The first thing I want to do is I want to find the answers to these using our ln button. So I'm going to move number 2 a little bit out of the way so we're not focused on it. And then we'll try number 1 with the calculator. And because this is the first time through this, I will actually use the calculator that is sitting here. So the first question I'm looking at is ln 2. So some of you are going to have to hit ln 2 and then probably equals. For me personally and my non-display calculator, I'm going to hit 2 and then I'm going to hit the ln button. And I get to 2 decimal places 0.69. Now I want to tell you what that means. First, I'll write down the answer. I think. Oh, there we go. What that means is that if you take the number e, 2.71828, and use an exponent of 0.69 on it, you will get an answer of 2. Now that will be approximate because number 1, that's approximate, and we round it. So the way your E button works is it knows that you have to apply an exponent. E's don't work any other way, so it's nice that they meaning the people who made this stuff up, it's nice that they knew that exponent started with an E, so they used an E. That's pretty nice of them. So if I put in the 0.69 and then hit my E button, which is programmed to know that the 0.69 is an exponent, I get approximately 2. That's wrong. This E button is funny. So I have to take that, use an exponent, and put on 0.69. And there, that's almost 2. So your calculator and my calculator will probably work a little bit different. Let's see if I have it here. Oh, there it is. That's the E button I was looking for. So 0.69, e to the x, means take the number I just inputted and use it as the x. And there we go. Whew, pressure was on. All right, next question. Ln 30. So take out the calculator, put in 30, hit the ln button, and we get 3.40, and that's approximate. And that means that if we take e to the exponent 3.40 approximately, we will get 30. So this time, I'm not going to botch my button pushing. You probably don't even have this button. I don't know why this calculator does. We'll need to access our second function button. Some of you may need to do it anyhow for the e to the x. So this is actually on there and it's unrounded. So I'm going to hit the e to the x button and see what happens. There we go, 30. And as you can see, e's and lns cancel each other out. So I'm going to avoid writing the red stuff down every time and just get the 3 answers for these next ones. So the next one is the ln of 1. So put 1 in, hit the ln button, I get a 0. And that is from the graph. Everybody should know the answer to the next question. Everybody should know this one as well. But the next question, I'm going to punch in 0 and then hit the ln button. Your calculator might work backwards. And you get an error, and that is expected. And it's expected because you can't take the log of anything that's not positive. And lns are just special logarithms. So the next question, and I'm going to have to access this button, this button here, because that's what most of you will have. I'm going to take 1 and put it on the e and get the actual value for e in its most exact form. And then I'm going to hit the ln button because that's what this is asking me to do. And it is not surprising that it's 1 because they cancel each other out. And when things cancel each other out, they don't leave 0, they leave 1. What that one is saying is that e to the 1 is equal to e. What this one is saying is e to the something is 0, and that something can't even be found. What this one is saying is e to the 0 is equal to 1, which is pretty logical if you think about it carefully, because anything to the 0 is 1. So in this case, e to the 0 is 1. All right, let's move on to question 2. And these questions are not find or evaluate questions like number 1. These questions are to solve for x. And this is where I get to teach you how e's and lns cancel each other out in the not so typical way. So I'm going to put 2 here and move these guys out of the way. Notice that these are all e to the x's and these are all ln x's of some form. So let's do this. All right, so here we have the situation that we had earlier in this unit, and that is an x or a variable in the exponent. And when that happens, you log both sides so that you can use the law of powers to bring that down. Well, I don't want to randomly log both sides. And if I know that lns and e's cancel each other out, that means I get to ln both sides. Now, I think about lawns as in front lawns, as in that space in front of your front porch. So lawn has to be applied in front of what was already there. So if I go on to the second question, it's the same deal. You put the lawn in front to cancel the e. And when that happens, you are allowed to imagine that this happens, which is not actually the case. So I'm going to, water break. So we get to cancel the ln and the e. And leave ourselves with x. And that's on the left. If you're at a school that doesn't let you use a calculator, x equals ln 5 is a perfectly acceptable answer. However, if you're at a school that does let you use a calculator, you may be expected to write down 1.61 if it's 2 decimal places, 1.6094 if it's 4 decimal places. Basically, you will follow the instructions for that. I'm going to go 2 decimal places, 1.61, because that's all my memory will let me hold. And basically that means if I put 1.61-ish in there, that'll equal 5. So in this one, the ln and the e will cancel out, and we'll be left with x. And we end up with that as our therefore statement. And then if you are at you're totally allowed to leave it like that, but if you're at a school that does let you use a calculator, you will get that answer. So I'll put or 1.39. Negative 1.39. All right, last question, same steps. I'm going to put in an extra line for this one. Technically, I could put a bracket around the 0.25, the 5, whatever I want to. I put a bracket around this because it was negative. Remember your actual law of powers, which lets you lower that x down in front. That means the ln and the e will cancel out and create 1, which means this is 1x is equal to ln negative 0.25. Now, if you're at a school that if you're at a school that doesn't let you use a calculator, this would be the wrong answer. And you should question that because, well, I was allowed to leave this one, and I was allowed to leave this one. The reason is, if you're at a school that doesn't let you use a calculator, you are expected to know when certain things happen. And a certain thing happens here, as in if I put in 2.5 and I make it negative and then hit the ln of it, I get an error. So this is actually no solution. And the reason is you are not allowed to log negatives. You're allowed to log positives. You are not allowed negatives or zeros. So we are done when it's no solution, rather than here, which says, I don't really know the rules of logarithms or natural logarithms. All right, next stuff. This is where we're solving for x, but I have a ln on the left. So I'm lnning x, so I want to know what number do I put in for the x that when I hit the ln button, I'll get 4.5. Another way to look at that is this, but there's an abbreviation. So there's an abbreviation for logarithms, and there's another abbreviation for natural logarithms. We mathematicians love our abbreviations. So here's how you do this question. You, and this is totally bad language, e both sides. But e has to be used with an exponent. So when you e both sides, this ln x becomes an exponent, and this 4.5 becomes an exponent. And it is totally okay to imagine this happening as long as there is nothing sitting right here. If there is something sitting right there, you would have to pull it up top beforehand. Now, none of this crossing out stuff is supposed to happen. You're supposed to imagine that it happens. And if you're at a school that doesn't let you use a calculator, this is your answer. We aren't there yet, so I can take 4.5, input it in, find my exponent e button, which is this guy, and get 90.02 if I'm rounding to 2 decimal places. Same thing, only more of it. Reminder, if you are trying to get rid of a ln, and I'm totally using air quotes with that, You have to apply an e to both sides so that you can cancel them out. But you have to put what was originally there on both sides up as an exponent. Again, there can be nothing here in the way between the e and the ln being beside each other. If that happens, you have to plop it up there before you go and start mentally canceling things out. Right now, I can mentally cancel these out because they're in a row and write down 2x plus 1 equals, I'm not going to do anything with this. I need the x by itself, so I'm going to take the 1 across the equal sign and subtract it. And then I'm going to divide both sides by 2 and end up with a therefore statement of x is equal to e to the 3 minus 1, all of it over 2. And that would be a perfectly acceptable answer at a school that doesn't let you use a calculator. We aren't there yet, so you're also okay to just put that into your calculator. So I'm putting in a 3. I'm using my e to the x button. I have to minus 1. I have to find that answer and then take that answer and divide it by 2, and I get 9.54 approximately. So here, both of these answers are perfectly acceptable. So I have some moving around to do on the next page. This note is quite short, I think. So I'm going to come back at you after a little hand cramp break. Okay, onward and upward. These questions are to simplify. That implies that you are going to use logarithm rules to simplify, because ln is a special logarithm. So all the rules, the law of powers, the law of multiplication or addition, the law of division or subtraction, all those rules work as long as you remember how to use them, which is a big part of calculus. So I'm going to move this down to give myself some space and look at this one first. So the part that makes me happy about this question is there's nothing here in front of this hidden logarithm, and nothing here, and nothing here, meaning we don't have anything to plop up so that we can use our rules. So I'm going to get rid of all the yellow and remind you about the rules. So the first rule I'm going to use is that I've got two logarithms, same base e. So I can take these two brackets and I can multiply them together, as long as I remember to keep a single logarithm instead of two of them. Minus the ln of x squared minus 1. We'll deal with that shortly. I am going to take this bracket and multiply it out because I see that there's something special about this. This is like a difference of squares factored. So I'm going to multiply it out. So x squared minus 1x plus 1x minus 1 minus ln of x squared minus 1. So that's ln x squared minus 1 makes 0. And I've got a subtraction sign here, which really means that I can take this x squared minus 1 and divide it, because subtraction and division are hooked together, by the x squared minus 1 that's sitting here with this ln. And then hopefully you recognize that anything, regardless of how messy it is, over itself is 1. And something that you should memorize or understand, especially if you're at a school that doesn't let you use a calculator, is that this answer is 0. And that is as simplified as we get. In fact, we could evaluate that one. Next question has some e's in it, a few actually. And I would love to cancel these things out, but the problem with me canceling those things out is I've got this little negative sign in the way, so I have to deal with that negative before I do any sort of canceling that should actually happen, not on paper but in your head. So I get to take that negative, which is actually a negative 1, and I get to put it up here. And now I get to imagine these things canceling out, which leaves me with 1 over e to the negative 1. And you should know that negatives flip. And I hope you know that 1s don't do anything, either as an exponent or a denominator. So there's the answer. And I am definitely not taking the time to write 2.71828 when I can just leave it as the number, air quote, e, just like pi is a number. All right, next question. This guy, C, even though D moved. So you would think that we could take ln E and cancel them out, but I don't want to do that, mostly because it's wrong. I realize that this is times. And times can be broken apart, or it can be put together, depending on its usefulness in whichever direction. So I'm actually going to take this single log that's in the top typewritten line, and I'm going to turn it into, for lack of a better phrase, a double ln. And now I can imagine that happening, which means the answer to that first little bit is a half, and the answer to the second little bit is 2/3. And now I have to get a common denominator. I'm going to do the 1, 2, 3 thing. 1, multiply those two together. 2, multiply those two together. 3, multiply those two together. And you get that. Just so you know, we could have taken these two pieces, kept an e, and added the exponents because the bases were the same, and got the 7/6. Then the e and the ln are in a row, they cancel, and you still end up with 7/6. Either way, you still have to add fractions, and you still have to get common denominators. All right, last question of simplification. Trig, whoa. First thing I notice is that the e and the ln are not in a row here. So we've got to deal with that. And the way you deal with it is the law of powers. So I'm going to do that. And then I'm going to explain this little 2, which is the same kind of 2 as with sine squared x or cos squared x or tan squared x. And that is, it really means that this whole quantity is being squared. In this part, these could cancel mentally, and you're left with cos x in a bracket squared, or I'm going to use its abbreviation, plus mentally these cancel, and you're left with sine x in a bracket squared, or that abbreviation. And last time I checked, this was my favorite trig identity, which is simply the number 1. So in all of these questions, you are able to evaluate rather than simplify, but simplifying is how you evaluate it. Now, just because I told you you have to do that mentally, I'm going to get rid of all that because it really shouldn't be sitting there. It should be in your mind. All right, last question. Oh my gosh, it's a compound interest question. It's all about the money. Do you remember what we do for compound interest questions? Compound interest questions. Pain. So, 7% divided by 100 divided by 4, because this is quarterly. Don't have my calculator handy, so I'll use this guy. 7% divided by 100 divided by 4 equals, I probably could have done that in my head, 0.0175. Oh, do you remember this stuff? If it's how long, that means I have no idea how many years it is, but I do know I have to times it by the special number, which is still 4. I'm depositing $8,000, so that is the principal, the beginning amount. And I really want to end up with $12,400. Hope this is possible. Probably not at 7%. And then the main formula for this is that. So let's plunk in our numbers. There we go. Move this 8,000 out of the way first. I hope that when I divide that, it's something nice. I can't promise. I can't do that in my head. 12400 divided by 8,000. I am willing to write that down. That's not that bad. So, when we did compound interest questions, I said that at this point you logged both sides, log base 10, because you had a log button, and that let you use the law of powers to pull the exponent down in front. It is entirely possible that you do the exact same thing with the ln button. What is not possible is that you do this, because that's mixing log base e with log base 10. You have to pick your base and stick with it. So I am going to, because this is a ln and e note, I'm going to ln both sides. And instead of me writing the 4y as an exponent, I'm going to plunk it down in front, which means to get the y by itself, I have to divide both sides by ln 1.0175, and I also have to get rid of the 4, so I have to divide both sides by 4. Oh, there we go. Ah! And y? So let's see what's under here. For me, 1.55 divided by, oh, bad me, 1.55, hit the ln button, divided by 1.0175, hit the ln button, divided by 4, don't hit the ln button, it was just a plain old 4, equals 50.96, so that's actually 51.0 years. Written completely wrong. And then a therefore statement. Therefore, it will take 50.0 years. So if I go back to the original question, if I deposit $8,000 into an account, I'm getting 7% annual interest and I'm compounded quarterly. I'm ending up, I want to wait until I get $12,400 in there. How long is this going to take? It's going to take a heck of a long time. It's going to take that one. And I've still got it wrong. That is 51.0. You might think that might not make any difference, but yeah, a year will make a difference. All right, so that is your ln and e note. It uses all the same rules, and you will use this in calculus class if you are ever taking calculus class. So that is all about today. Oh, yay, under 30 minutes.